Assalamualaikum everyone. So first and foremost, let us introduce ourselves. Me myself, Syafiq bin Azhar, and my group mates, Harun Nizam bin Hashim, Muhammad Azri bin Maslan, and also Muhammad Izzat bin Fawzi. So here we are to present about the operational amplifier, which is the source flower amplifier. That's right. So let's see the application of the operational amplifier, which is the OMs are essential components in electrical circuits. They are usually used in a wide range of applications from simple amplification to complex signal processing. Thus, in this presentation, we will explore the basic operational amplifier and also its practical uses. So what is op-amp usually? By definition, the op-amp is a type of integrated circuit that amplifies the difference between the two input voltages. And its symbol is a triangle with one input at the positive terminal, then one at the negative terminal, so one at the output. And its key features is it has high gain, high input impedance, low output impedance, and also differential output.
Okay, thank you, Shami, for your presentation. So next we move to the basic op amps circuit that we have for the simplest. So there is three. So the first one is inverting amplifier. So this one is a amplifier that produce an output that is 180 degree out of phase with the input signal. Next is the non-inverting amplifier. It's a positive voltage gain and does not invert the input signal. Then the lastly is the summing amplifier. The will calculate the sum of multiple input voltage with the individual gain of adjustments. Okay, next slide. Okay, thank you. So this will be about the application of our chosen application, which is the source follower amplifier. So for this, we have three things we need to understand. The first one is principle of operation. So for this principle, it use a file effect resistor or BJT, and there's the principal operation we can simplify by three steps or three things. For the first one is the input stage. The input signal is applied to the gate of the FET or base for the BJT. Then the output stage is the output is taken from the source of the FET or the emitter of the BJT. Then the application is occur when the input signal cause a variation in the voltage at the output and providing the application. So next is the usage or the what we will use for the source follower amplifier. There's two. The first one is buffering, which they will act as the voltage buffer, isolating the input from the output. Then the second one is the impedance matching. For this occur when the source follower has a high input of impedance and low output of impedance. Then what is the advantage of using the source follower amplifier? There is four. The first one is the high input impedance. They will present a high impedance to the input signal source, meaning they don't draw much current from the source. The second one is low output impedance. The output impedance is low, which allow them to drive load effectively. The third one is unity gain. An ideal source follower, the voltage gain is close to the unity. The last one, the average stage, is the simple design. So they often have the straightforward design and easy to design and make for them. So I think that's from me. Next, Azrin.
Okay, so thank you, Haruniza. So now I will talk about the simulation and the result for the source follower amplifier. So I will share my screen on the cadence. Right, so here's the source follower amplifier simulated in the cadence environment. As you can see, we are using one NMOS using the 30 nanometer technology. And this is the property for the NMOS. The NMOS is equipped with the finger weight of 10 micro, the light of 130 nano. So then we set the source of V sign at the gate, so at the gate, and the DC voltage at the drain source. So as for the V sign, we are using the 500 millivolt for the DC voltage, 2 millivolt for the AC amplitude, and the offset voltage is 1 volt, and the frequency for the sine wave is 1 kilohertz. And for the VDC, we are using just 1 DC voltage. And then we set the resistance at the source gate of the NMOS. So when we simulate it using the cadence environment, using the trans analysis of 10 macro, this is the waveform that we will achieve from the circuit that we design, where the V in is higher than the V out. V out is at peak is 939 millivolt, and the V in is almost 2 volt. If we want to adjust the voltage, we can adjust the weight of the NMOS. This will slightly decrease the V out voltage. As you can see here, just now is 949. So by decreasing the weight of the NMOS, we will decrease the voltage at peak of the V out and also the V in. So if you want to increase or decrease, we will need to adjust the weight and the length for the NMOS, and also we can alter with the DC voltage, the V sign, to make the output voltage become higher or lower. The resistance value doesn't give any effect towards the output waveform. So it's important to note that the NMOS really depend on the wave size to perform and achieve what waveform that we are needed. So checking the slide. Okay, I believe that is all from me, and this the analysis that we are using in the cadence experiment, and this is the property for the NMOS. So that's all from me. I pass to Izzat.
So I will proceed the presentation with the industrial application for operation amplifier source follower in telecommunication industry. First one is impedance matching. Source followers are utilized to match the impedance of high impedance signal sources, for example, antenna or transducer, to the low impedance input of communication equipment, such as receiver or transceiver. This impedance matching ensure efficient power transfer and minimize signal reflection, optimizing signal reception and transmission. Second one is buffering and signal conditioning. Source followers with OM are employed to buffer and condition signal before they are transmitted over communication line. This is crucial for maintaining signal integrity and preventing signal degradation due to long cable runs or other factor. And last one is transducer interface. Telecommunication system may incorporate various sensor and transducer, such as those used in environmental monitoring or remote sensing. Source followers can interface with this sensor, ensuring that the signal generated are properly conditioned and matched to the input requirement of data transmission or processing equipment. Next, in conclusion, operational amplifier are versatile and essential component of modern electronic circuit, enabling a wide range of signal processing and control application. Second one is future development. Ongoing advancement in OM technology continue to expand their capabilities for high performance and low power application. And the third one is impact. The adaptability and efficient of operational amplifier contribute significantly to advancement in electronic and electrical engineering. So that's all from us.